So this is Epsom salt. People usually put this in baths, but chemically it's actually magnesium sulfate heptahydrate, which means it contains 7 water molecules locked into the crystal structure. What I want to see is whether we can remove the water and turn this into an anhydrous magnesium sulfate, which is commonly used as a drying agent in chemistry. The formula for Epsom salt is MgSO4 7H2O. If we heat it, those water molecules will leave as steam, and we are left with plain MgSO4. This doesn't decompose the compound, it just removes the water. Magnesium sulfate can be easily obtained from most pharmacy stores or supermarkets. Now, if you're going to try this yourself at home, it's important to know that you have to get the fragrance-free Epsom salt. Making sure that there is no additives in the ingredients besides magnesium sulfate is crucial. Now to start, we're going to weigh our beaker that we'll be using for the reaction. The mass of our beaker is 29.445 grams. We will be using 1 gram of magnesium sulfate heptahydrate approximately for our reaction. Now we will add about 1 gram to our beaker. Now this is actually 1.019 grams magnesium sulfate heptahydrate, but that's fine. Now we're going to set up our hot plate and place our compound on top. I'm going to start by heating it to 120 degrees Celsius. If you have access to, I highly recommend using a watch glass. This can help avoid some of the crystals popping out of the glass. It is important to leave a small gap where the mouth of the beaker is. Steam will be produced in the formation of the anhydrous magnesium sulfate. As this heats up, the first thing you'll notice is steam coming off. That's not the compound breaking down, that's the water that was previously trapped inside the crystal structure. You can also see the crystals shrinking and turning opaque as the structure collapses. At this point, it still looks slightly clumpy, which means there's probably still water left. So I'm going to keep heating it a bit longer and see what happens. But if you listen closely, you can hear the steam coming off. It's like a slight sizzling and popping sound. Now I'm getting some crystals shooting out of the glass as it heats, so I'm going to put this back on. This time, I'm going to put it all the way up to 250 degrees Celsius. Now I will move the watch plate carefully to let more steam evolve out. If you look carefully, you can see crystals shooting around in the glass. Now that it's been a few more minutes, I'm going to remove the watch glass and give it a stir because I see water recondensing back into the beaker. I want to try and help break up any clumps and any pockets of moisture. Now I'm going to leave this without the watch glass on top, as most of the water has been removed from the magnesium sulfate. And we don't want water recondensing back in, as the magnesium sulfate will quickly absorb that. Now that it's been a few more minutes, I'm going to turn the heat off and take it off to let it cool. Now I'm going to remass this to see how it compares to our previous 30.464 grams. After the first drying, we are left with 30.010 grams. We lost 0.454 grams. Now we're going to heat this again at 250 degrees Celsius to see if we lose any more weight. If we do, that means that there is still some water that is trapped in the magnesium sulfate. Now again, we're going to take this off the heat and let it cool. Now that our beaker has cooled, we're going to mass it again. This time, again, we're left with exactly 30.010 grams. That means we were lucky enough on our first run to have completely converted it to the anhydrous form of magnesium sulfate. You know your magnesium sulfate has been completely converted to its anhydrous form when, after the second or third or even fourth heating, the mass does not change. That means that all water has been released out of the product. Now we are left with this fine white powder. It no longer looks like the original heptahydrate, which are these beautiful crystals. Seems we also got a piece of contamination in our product. Now for fun, let's see what happens when we rehydrate the product. The powder begins to clump up again as more water is added. Now, it seems to be that our contamination has gotten worse. Also, the reaction is slightly exothermic, which I didn't expect. So that's how you can turn ordinary Epsom salt into anhydrous magnesium sulfate using nothing more than heat. Thanks for watching.